Hey guys, right now I'm going to do number 3 for problem set 8 for AP Physics 1. You can kind of see that number 3 is cut off at the bottom here, so I'm just going to be showing the diagram at the top. Alright, number 3 is asking us to find the coefficient of friction. So what I'm going to do first is draw the diagram. We have an object here with mass m, and it is accelerating in a certain direction at 3.4 meters per second squared. Now, from the frictional equation, we know that the force of friction is equal to the coefficient of friction, in this case kinetic friction, times normal force. So we know that the coefficient of kinetic friction is equal to the force of friction over normal force. This means that to find the coefficient of friction, we must find the magnitude of the frictional force and the normal force, and then divide them to each other. What I'm going to do first is label all of the forces acting upon our object, and we know very clearly that there is a gravitational force, and the gravitational force is equal to mass times the gravitational acceleration, in this case 9.81. So our gravitational force is 9.81 times the mass. Next, I'm going to break this gravitational vector into components such that this bottom vector is parallel to the direction of motion. Since this angle is 24 degrees, we know that this angle is also 24 degrees. Next, I want to find the force of this component of this gravitational vector because it is parallel to the direction of motion, and therefore it has to do with the friction of the object. So I'm going to label this force as this component as x2, and we can find what x2 equals the magnitude using trigonometry. We know that the sine of 24 degrees is equal to this force x2 over 9.81 m times the mass. So we know that this component is equal to 9.81 times mass times the sine of 24 degrees. Okay. Now, right now I want to go off tangent here and show you an example to demonstrate what I'm about to do next. If you have an object here, and we have one force acting upon the object in this direction with a magnitude of 5 newtons. Now, let's say the net force of the object is 3 newtons. Therefore, there must be some kind of opposing force acting upon the object, and to find that opposing force, we would take this force, 5 newtons, minus the net force, which is 3 newtons, and that would give us 2 newtons. That means the opposing force is 2 newtons. Now, the same principles apply to finding friction. We know that the object is moving in this direction, and the net force is 3.4 times the mass, because the acceleration is 3.4, and force is acceleration times mass. Now that we know that net force is 3.4 m, and we know that this force is 9.81 m times sine of 24 degrees, we also know that there is some kind of opposing force. This opposing force is friction. So, relating to the example I just showed you, to find this opposing force, we would take this force, which is 9.81 m sine of 24 degrees, and we subtract the net force, which is 3.4 m times mass, and this would give us the magnitude of the opposing force, and this opposing force is friction. So our frictional force is equal to this value right here. This is the magnitude. Next, we want to find what the normal force is equal to, and that's pretty easy because normal force is perpendicular to the object. So we just want to find the magnitude of this vector right here, and I will label it y2. I'm going to use trigonometric equations. We know that the cosine of 24 degrees is equal to y2 over 9.81m. So we know that the y2 force is equal to 9.81 times mass times cosine of 24 degrees. And this is our normal force. This is our frictional force. So we can see that our coefficient of kinematic friction is equal to 9.81 times mass times sine of 24 degrees minus 3.4 times the mass, which is the frictional force, divided by the normal force, which is 9.81 times mass times cosine of 24 degrees. You can see here that the mass cancels out. And I'm going to get a calculator to find what this equals. And it's equal to around 0.065844. So this is the value of our coefficient of kinematic friction.